Math 3, Unit 8, Section 6. Today we're talking about the empirical rule, also known as the 68, 95, 99.7 rule. What this means is basically on your bell curve, 99.7% of the data will fall within 3 standard deviations. And we're going to go through this, but we're going to go ahead and read this paragraph here. Properties of normal distribution. Besides the fact that the curve is continuous, one property of normal distribution is the area under the curve. The area under the curve represents the probability of several events. In this section, we will explore some of the basic properties for normal distribution. One of the first things that you need to know about every curve is the total area under the curve is equal to 1 or 100%. Okay? In statistics, the empirical rule states almost all the data will fall within 3 standard deviations of the mean. 68% of the data will be within 1 standard deviation, so this is where the 68 is coming from. So 68 is within 1 standard deviation. 95% of the data will be within 2 standard deviations, and 99.7% of the data will be within 3 standard deviations. So almost all the data will be within 3 standard deviations. So looking at this chart for your normal distribution, first of all, if you notice here, this is cut down the middle, okay? While this says 0 right here, this is where your mean would be. So if I said the class average or the mean was 50, we'd have a 50 here, okay? But if we're looking at percents, how much do you think this whole half side, what percent is that? 50. You guys are smart. Okay, so that is 50%. And over here, this is also 50% of our data. Now, they told us, and right here, this is 1 standard deviation. So you can go 1 standard deviation in both directions, okay? And if you look back up here with our empirical rule, 1 standard deviation was how much? 68%. And so if you're splitting this up, we would take 68, cut it in half. So each one of these is how much? 34. Okay, so this whole thing is 68. We split it in half, so each side here is 34%. Is that good? Okay, then they say that 2 standard deviations is how much? 95%. Okay, so we already know that this is 68%, correct? So how could I figure out how much these pieces right here are? What would we do? Very good. So I'm going to take 95 minus 68, which is how much? Okay, we have to borrow. Or you could use a calculator. And then 15 minus 8 is, thank you. Okay, that was tough. I didn't know that. Okay, so 27. That means this and this together make 27. So how do I figure out how much goes in each spot there? 14.5. Very good. Divide by 2, which is actually 13.5. So right here, this is 13.5% of the data, and this is 13.5%. And actually, we can make these percents. But really, it's just important that you remember those numbers. Okay, and then the last one, 3 standard deviations, they said was how much? 99.7% of the data is within 3 standard deviations. Okay, so we know that 2 was 95, so how do we figure out how much these 2 little pieces are? Exactly. So we're going to go 99.7 minus 95, which is 4.7. And if we're splitting that up between 2 little pieces here, what do we do? Very good. Divide by 2, which is 2.35. Now, how do we figure out what's left over after the 3 standard deviations? Exactly, 100. So if you take 100 minus 99.7, what do you get? 0.3. And then to split that up, we would divide by 2, which is 0.15. So these last parts, the leftover pieces, are 0.15. Okay, any questions? So you have to, if you remember the 68, 95, and 99.7, you should be able to fill in this whole normal distribution, and it will help finding information much easier. Okay, we're going to move on to some examples. Okay, example 1. A research was performed on the IQ scores of a private firm with 800 employees. It's important to know that how many pieces of data are within what you're finding. Okay, so there's 800 pieces of data here. It says the scores are noted to be in normal distribution, so they're telling us the scores will fit within our normal distribution curve. They told us that the mean is 100. So when they tell us that the mean is 100, it is saying that if you cut this down here, the mean right here, the average score is 100. Okay, and then it says, and the standard deviation is 15. Okay, so I like to mark these lines. You can do whatever you want to do, but for me it's easier to see. And when they tell us that the standard deviation is 15, that means that we would count 15 going for each of these standard deviation marks. So my next mark right here would be what? 100 plus 15 is 115. Good. Okay, so then my next standard deviation would be 130. And then over here would be 145. Now what would I do for the opposite direction? Yeah, subtract 15, right? So it's going the negative 1 standard deviation. And so 100 minus 15 would be 85. And then the next one would be, and then 55. Okay, so these numbers right here are important. It's important to know what your mean is and your standard deviation, okay? And then we also need to know the percentages, because as we get into the question, it's asking me what percent of the scores are between 70 and 130. Good, and I heard somebody say the answer. They said 95%, which is correct. Okay, but sometimes, and we'll go ahead and write that, 95%. How did we know that that was 95%? Yeah, from your notes. Very good. Okay, let's go ahead though and mark in all of our numbers again. Okay, so we know that 1 standard deviation is what percent? 68, and we divide that by 2, which means that each of these pieces is 34%. So we're going to write 34% for each of these. Okay, we know that going out 2 standard deviations was 95. And so if we don't remember, we can go 95 minus 68, which is 27, and 27 divided by 2 was 13.5, so each of these are going to be 13.5%. And then we know 3 standard deviations was 99.7. If we go 99.7 minus 95, we get, I forget, and then we divide that by 2, and so each of these are 2.35. Good. And then the last ones are 100 minus the 99.7, which is 0.3. We divide that by 2, and I get 0.15%. Okay. Now, if you had this filled in like this, and you had the 70 to 130, you could just add all those up in your calculator. You could go 13.5 plus 13.5 plus 34 plus 34, and you get 95. Okay? Next one, between 85 and 115. Very good. 68% is correct. Okay, C, I'm going to give you like 30 seconds to get that answer. Okay, what is it? Good job. 81.5%. What percent of the scores is greater than 115? So that means that we're going to 115, and anything that's greater, we're adding those up. Very good, 16% is correct. Okay, what percent of the scores is less than 100? So here's 100. Notice that that's right in the middle. So while you could add all those up, we should know that it's 50. Okay, but if you added it, it still would equal to 50%. Okay, now F is a little different. It says approximately how many employees, so notice they're not asking for a percentile this time. How many employees scored between 85 and 100? In your groups right now, I want you to talk about how do you think you could figure that out? How many groups think they have an idea of what they should do? Okay. So I'm going to tell you that there are 2 pieces of information you need in order to get this answer. Okay. Can somebody tell me one piece of information you need to know? Sochi. Very good. We need to know how many employees there are. Did they tell us how many employees there are? Yes. How many? 800. Okay. The second piece of information, can somebody tell me what is the second piece of information I need? Okay. The percentile. Okay, and so what percent is in between 85 and 100? 34. So do I take 800 times 34? No. What do we multiply by? 0.34. You have to change your percent into a decimal, which is 0.34. So we multiply those together, and did anybody get the answer? Very good. And it's specifically 272 what? Employees. Okay, go ahead and try G on your own. No. Because we're finding what percent of employees are in that range, and so we know that the whole thing is 800, and so we know 34% is within that range, and so once you multiply by that 34%, that tells you how many employees are in that range. Now if they said how many were not in that range, then you would find that answer and subtract from 800. Okay? So if you get the answer, raise your hand and I'll come check it. So remember, there's those little pieces, the 0.15. Does that make sense what I'm saying? Okay. Think about it. What percentile is that? Like how much percent was it when you added all that up? You got 70%. But I don't know how. I don't even. Yeah, I don't usually never I round it out. I would do something like this. Because you can't have a portion of a person. Yeah. And so if they're saying that you would have this much, you would round it out. This one I think that you would. So That's fine. Okay, so look. Yeah, so yours is a little off, so let's check. Yeah, that's what I got. Good. Okay, so the answer should have got was 797 or 798. I'll kind of confirm on if we should be rounding up or rounding down. I was doing on these normal rounding. Like if you get 0.6, you round up. If you got 0.4, you would round down. If this was a test, I would give you probably either one. Okay, but 55 to 145, it goes out 3 standard deviations. Do you guys agree? Do you remember what the percent is for 3 standard deviations? Okay, so if you go 100 minus 99.7, what do you get left over? 0.3. Do you guys agree with that? Now, you could also add all of them up if you wanted to. Okay. So anyways, and I don't even know why I got the 0.3 left over, but I just wanted to show you what was left over. Okay, so you had 2 options. You could have gone 100 minus 0.3, or you could add them all up. But no matter what, it's 0.997 is our percent. And we're multiplying that by 800. And when you do, you get 797.6, which is, we're going to round up to 798 employees. If you put the other, I'll get back to you. Do you guys have a question for me? Am I saying something wrong? We're good? Okay. All right. G. Did we do G? Okay. You guys want a minute? If you have the answer, raise your hand. I'll come check. Oh, there you go. Good job. You're so So is this greater than 70? So here's 70, right? So you can either add all of those, or you could add these two and subtract. Okay? Okay, now your question was what? So, I know. Or I know that just say turn goes like this. Huh? Good. Perfect. Okay, good. Don't forget employee transfer. Okay, so 780 was the correct answer. Did we get it? Yes? Okay, so it says greater than 70. So if you go here, greater than 70 is all these numbers. Now, you can add all those numbers if you want to, or I could add these two numbers and subtract it from 100. It's kind of up to you on what makes more sense and the kind of work you do. I like to do the least amount of work as possible, and so I would add those 2 decimal places. And when you added those 2 decimal places, it was 2.5. Does that sound right? Okay, good. And 100 minus 2.5 is 97.5%. Okay, so 800 times 0.975 equals 780 employees. Do you have any questions for me? Okay. Question? All right, last one, example 2. It says, in a normal distribution of Ford F-150 prices, 99.7% of buyers paid between $25,000 to $37,000. What are the mean and the standard deviation? Okay, so 99.7. How many standard deviations does that go out? 3. So that means that so we have our mean, right? And maybe we should go ahead and mark these. For me, I just like seeing the marks. You don't have to do this. But they're saying the 3 standard deviations right here, these are your values. So that means, where does the 25,000 go? The one furthest to the left, the 3 standard deviations to the left. Okay, so that right there is 25,000. And I kind of wrote that too big. You're going to want to make it smaller together. And then where does the 37,000 go? At the end right here, okay? So 37,000. Now they want us to fill in all the rest of the information, and specifically though, I think really, they just want us to find the mean, but then they want to know, what is the standard deviation? How much are you adding between each standard deviation? So how could I do this? Okay, talk in your groups. I want to hear some ideas. What do you guys think? It was a good thought, though. You remembered learning about it. Okay, anybody want to share out what you guys think? Robert, come on, show me. What do you think? Listen up, you guys.
3 days.
What I did was took the average of the 2 numbers, and I got the mean.
Okay, the average of the 2 numbers to get the mean, would that work?
Yeah.
And then I just went off from there and just guessed it, but it was a super accurate.
Okay, and so you could use guess and check. I think all of that totally works. There is a mathematical way, okay, but guess and check is another way, and guess and check is mathematical. So it's good. That is good. Anybody else come up with something else?
I like the Robert.
Okay, I'm going to show you 2 ways. So, first of all, the way Robert explained. Let's go ahead and do that and see what happens. So, he took 25,000 and 37,000. Now, do I have to keep my thousands, or are you guys okay with me just taking the average of 25 and 37? Okay, so we're going to go 25 plus 37, and if we're taking the average, we're going to end up dividing that by 2. So 25 plus 37 is how much? 62, and we divide that by 2, and what do we get? 31,000, okay? Would everybody agree with that? Okay, that is one way. Another way. Anyone have an idea? There's another way. This way's good though, totally good. Okay, I'm just going to help you out here. If you want to figure out 37 and 25, what amount does it go up? Okay, so 37 minus 25 is 12,000. So from here all the way to here, it's 12,000. Okay? What could you do with that information? You could divide it and separate it between your sections, right? Could I divide that value by 2 and know that from here to here it's 6,000, and then from here to here it's 6,000? So if you do 25, because if I take 12,000 and just divide it by 2, cut that value in half, I get 6,000. So that means from 25 to get to my mean, my middle value, I would add 6,000 to it, which is also 31,000. So see how we got the same answer? Both ways work. It's kind of a way of double checking myself. Okay, now what is the distance from here to here? Or like how much does it go up? We know. 6,000. So if I want to evenly distribute that between how many? 2, how much would I add for each one? What was it? 3,000. So let's see if this works. So 25 plus 3 will give me 28,000. 28,000 plus 3 would give me, what will it give me? Did that work? Did 3,000 work? Okay, what should we add? 2,000. Okay, so 25 plus 2 is how much? 27. 27 plus 2,000 gives me 29,000. 29 plus 2 gives me 31. Still another check, right? 31 plus 2 gives me 33,000. 33 plus 2 gives me 35. And 35 plus 2 gives me 37. So, well, that's why I let us do that. You guys said 3,000. And so we added 3,000, but it didn't work out right for me to get to my mean. Because when I added 3,000 to 25, I got 28. And when I added 28 plus 3, I got 31. But 31 is supposed to be my middle, so I did something wrong. Okay, so we knew that this distance was 6,000, but you guys just cut that in half. But I really need to cut it into what? 3. Okay, 6,000 divided by 3 was 2,000. And so from here to here, you're adding a 2,000, you're adding another 2,000, and another 2,000. So does that make sense why that 6,000 we're actually dividing it by 3? And there's how many standard deviations there? 3. And then we keep going. Any questions? So my answers are, what is the mean? The mean was 31,000. And my standard deviation was how much? 2,000. And by filling in my whole chart here, it just made me double check that I know I have the correct answer because it all worked out perfectly. Okay, did I have to fill in that whole chart? No, definitely not, but I recommend always doing that to make sure you do it right. Any questions?